Hi, my name is Kirsten Safakis, and I'm a Community Involvement Coordinator for the U.S. Environmental Protection Agency. I'd like to welcome you to this virtual public meeting regarding the newly released proposed plan for the PIKE and Mulbury Streets PCE Plume Superfund site. For those of you who have attended an EPA public meeting in the past, you can see that we have had to make adjustments to our meeting format in an effort to ensure public safety during the ongoing COVID-19 pandemic. We hope that you will find this presentation and our outreach methods helpful and informative. The purpose of this virtual meeting is to provide some background on the PIKE and Mulbury PCE Plume Superfund site and the work that EPA has overseen in the community of Martinsville. We'll provide you with details about the investigation, as well as the cleanup plan that is being proposed as a result. The purpose of every EPA proposed plan is to gather the public's comments and questions about the proposed cleanup. After a 30-day public comment period, we will provide responses in a record of decision document. There are many ways you can submit your questions or comments to the EPA. First, you can submit a comment directly on this website. Next, you can leave a confidential voicemail at 312-886-6015 or fax your comments directly to my inbox at 312-697-2568. You can email me at safakis.kirsten@epa.gov. That's SAFAKAS.KIRSTIN@epa.gov. Or finally, you can mail me a hard copy statement to Kirsten Safakis at the U.S. EPA, 77 West Jackson Boulevard, 19th floor, in Chicago, Illinois, 60604. We recognize that you may have questions regarding the proposed cleanup plan after watching our presentation. We would like to invite you to call us during an open Q&A session to be held on Wednesday, August 12th from 6 to 8 p.m. Eastern Time. The dial-in number for that session is 312-667-5632, and the conference code is 1344648. Once again, that number is 312-667-5632 with the conference code 1344648. We will now start our presentation on the proposed cleanup plan. I will hand it over to the EPA Remedial Project Manager, Mr. Eric Hardin.
Thanks, Kirsten. For my portion of this presentation, I'll start with a brief history of what has happened with the site and how we got to where we are today. Then, I'll briefly discuss the results of our investigation, followed by a discussion of the cleanup options EPA evaluated and the specific options we are proposing. To summarize up front what we are proposing, for the contamination in groundwater, we propose a process called in situ chemical oxidation. We are also proposing to continue treating the city's municipal water supply with carbon until the groundwater is cleaned up. For the vapor contamination in the soil, EPA is proposing to use a process called soil vapor extraction, and if future sampling shows it is needed, to also remove portions of contaminated soil. EPA is also proposing to conduct additional sampling in and under homes and businesses to look for these contaminant vapors. Where we find these vapors at concerning levels, we are also proposing to install devices on the home or business that keep underground vapors from getting inside. Slide 7. The PIKE and Mulbury Streets PCE Plume Superfund site consists of what is called a plume of contamination in groundwater. Groundwater is an underground supply of fresh water that exists in individual pockets called aquifers. In this case, we are dealing with the first level of aquifer encountered underground, which is called the superficial aquifer. The term plume refers to an area of contamination. In this case, the contaminant we are dealing with in the groundwater is tetrachloroethylene. Tetrachloroethylene is more commonly referred to as PCE or PIRC. This is the primary chemical used for dry cleaning. We also found contamination in soil vapor. Soil vapor refers to the air spaces underground above the water table. At this site, not only did we find PCE in soil vapor, we also found trichloroethylene, or TCE. PCE and TCE are similar compounds, and it is very common for us to find these together. EPA's investigation of this contamination led us to the conclusion that there are two ways they pose a potential health threat to folks living and working in this area. One of those potential health threats is from drinking untreated groundwater. For this problem, the city of Martinsville continues to treat its water with carbon before anyone drinks it, which is effective at removing PCE. We want to make sure that no one is drinking from an untreated well that is drawing water from this plume. We put effort into finding any private wells, but we can't say for sure that we have identified all of them. We were able to test the few private wells we found, and they were in the clear, but those wells were located more at the edges or off to the side of the plume. If you have a private well, please let me or the city know so that we can get it tested. And at a minimum, don't drink from that well until it's been tested. I should also mention here that this isn't the only contamination in the area. The second potential health threat is from something called vapor intrusion. That describes a process where contaminated soil vapor makes its way into homes or other structures through cracks in the basement floor, sump pits, floor drains, and so on. These vapors can then accumulate in the indoor air at dangerous levels. EPA studied this thoroughly as part of our investigation. However, of the approximately 230 properties we determined should be tested, only 50 property owners gave us permission to test. We found definite issues at 2, but there were others we want to look at again. We expect to do more testing in the future and hope that more property owners will agree to this testing. PCE and TCE vapors have been shown to be harmful to breathe in, so we strongly encourage those property owners to agree to this testing. Except in rare cases, EPA needs written permission from property owners to do this testing. Please reach out to Kirsten or me if you have concerns about vapors in your home, or want to otherwise inquire about testing. Otherwise, I hope to be sending out letters asking for permission to test by early next year. EPA is leading the work on this site, with IDEM in an oversight role. We couldn't find a responsible party to do the work, which means all the work is being paid for by the EPA. The benefit of this is that things can sometimes move more quickly, if there isn't a need to go through the legal process of trying to force a responsible party to do the work. I'd like to now give a quick history of the site. The primary facility that led to the contamination, or at least got EPA involved in the site in the first place, was a company called Masterware, which was an industrial dry cleaner that operated just off the square in Martinsville's downtown from 1986 through 1991. There were multiple reports of spills or leaks from this facility that resulted in chemicals being released into the environment. IDEM removed some drums containing chemicals in 1992, and some investigations occurred there afterwards. Something to note here is that, based on where the groundwater plume is located, it's safe to say that Masterware isn't the only facility that contributed to the groundwater contamination at the site. EPA did a thorough search to find a responsible party, but we couldn't find any that were still viable and financially able to pay for this cleanup. PCE was first detected in Martinsville's municipal well field in 2002. The chemical was found in one of the 3 wells, and the city stopped using that well until they were able to get a carbon treatment system online. This led to an investigation by IDEM that rolled through 2003 and 2004. I've summarized some of the major findings on this slide. That investigation by IDEM led to EPA's Superfund program getting involved, and from 2005 through 2008, EPA oversaw what is called a time-critical removal action, which is EPA's process for quickly addressing some of the more serious health threats. These are usually short-term fixes. The other Superfund program is called Remedial, and that's the program I am in. We work on long-term fixes for the problem. The removal action that EPA oversaw at Masterware was paid for by an insurance company and directly run by its contractors. The main cleanup work they did was a process called air sparging and soil vapor extraction. Air sparging involves bubbling air into the contaminated groundwater, which causes the contamination to turn into a gas and move up into the soil vapor above the water table. The soil vapor extraction part of it's like an underground vacuum, where underground piping is used to draw the contaminated vapor and safely remove it from below ground. As part of this cleanup work, a few homes and businesses in the area were equipped with the devices I mentioned earlier that keep vapors from getting inside. I'll talk a little bit more about these systems later, as we are proposing to install more of these as needed. In 2008, all the cleanup levels for this removal action were met, and the systems were shut down. A couple of years later, IDEM did follow-up testing and found out there was still some contamination in the groundwater. The levels were nothing close to what they were before the removal action, but still above levels considered safe to drink. This is also where it was first determined that masterware wasn't the only source of the groundwater contamination. This follow-up testing by IDEM led to the site being listed on the National Priorities List in 2013, which is what makes it a Superfund site. As a Superfund site, it is eligible for federal money to investigate and clean it up. In 2014, EPA hired a contractor to start investigating the site on its behalf. Before I talk about the investigation, it is important for me to first talk about the Superfund remedial process. Again, the remedial process is used to fully clean up a site, not just address the immediate threats like is done with the removal process. The remedial process starts with identification of the site. We then do an investigation, generating something called a remedial investigation report, which is available on our website. After that, we evaluate the possible cleanup options and generate another report called a feasibility study report. This is also available on our website. EPA uses the feasibility study to generate the proposed cleanup plan, which is what we are presenting to you now. Kirsten and I hope you all will look at that document and give us any comments you might have, as EPA will consider these comments and then select the final cleanup plan in a document called a Record of Decision. EPA will hire a contractor to do the cleanup design plan and a separate contractor to construct and operate the remedy until cleanup levels are met. Note that the remedial investigation and feasibility study reports, as well as the proposed plan, are all on EPA's website for the Pike and Mulberry Streets PCE Plume site. I will now discuss the investigation at the Pike and Mulberry site. The sampling work was conducted in 7 phases, from 2015 through 2017. You can see a detailed description of how the sampling was conducted and what the results were in the remedial investigation report. What I am presenting here is just a summary of what we found. In the early phases, EPA was more focused on the groundwater investigation. We mapped out the plume at this site, which starts southeast of the town square and migrates to the northwest, eventually making its way to the municipal well field where it likely ends. Geologists use the term migrate instead of flow when talking about groundwater because it moves much slower than something like a river or stream. We measured the Pike and Mulberry plume to be migrating between 34 and 89 feet per year. The PCE concentrations we measured in groundwater range from just above EPA's safe drinking water standard of 5 parts per billion to as high as 240 parts per billion. Parts per billion is a way of describing concentration. You might also see this in some reports described as micrograms per liter, because 1 liter of water weighs a billion micrograms. When it came to soil vapor, the results were higher than I expected. As a result, we needed to investigate soil vapor more thoroughly, and that ended up getting shifted into later phases. We saw numbers high enough that we became concerned that harmful vapors could accumulate in homes or workplaces, so the last 2 phases of the investigation were mostly involved in doing these vapor intrusion investigations. Just for comparison, soil vapor concentrations are mostly reported in micrograms of contamination per cubic meter of air, and converting air concentrations to parts per billion is not quite as straightforward. We didn't find much soil contamination. What I'm referencing is actual liquid droplets attached to soil particles. This may be something we investigate a bit more moving forward because soil contamination can be difficult to find. Soil contamination doesn't migrate easily, and it can be nestled away under buildings or behind underground utilities, making it hard to sample. PCE is volatile, though, meaning it turns into a gas at room temperature, so any soil contamination will slowly evaporate into soil vapor if it doesn't get dissolved into groundwater first. Therefore, in theory, if soil contamination exists but we can't get to it, and we are cleaning up the surrounding soil vapor and groundwater, eventually that hidden soil contamination should dissipate. This is Figure 5-3 from the Remedial Investigation Report, and it's also Figure 1-10 from the Feasibility Study Report. I put it in this presentation to give viewers a feel for the extent of the groundwater plume. First, let me point out that these plume maps are generated by a computer program based on samples from groundwater monitoring wells, essentially connecting dots and estimating how big the plume may be. The orange area on this map represents where PCE concentration is between 5 and 46 parts per billion. The green is 46 to 100 parts per billion, and the blue is greater than 100 parts per billion. If you pull up those reports and zoom in on this map, you can see that our investigation found that the groundwater plume begins to the southeast near the intersection of Jackson and Sycamore. It then extends to the northwest, up to the city's well field. There is also a leg of this plume to the west. This is based on results from a couple of wells that were sampled. The computer connected these to our plume, but we can't say for sure that these really are connected. Regardless, it is something we will be keeping an eye on. This next map is the plume of PCE and soil vapor. This is from Figure 5-7 in the Remedial Investigation Report, which is also Figure 1-13 in the Feasibility Study Report. Again, this is based on sampling from individual points followed by some connecting of the dots. In this case, the red dots are points where we wanted to do further investigation, because those samples were above our lowest screening levels for PCE. The green dots are where we found concentrations below our lowest screening level. Our models didn't connect the dots quite as continuously in this one, but you see it's a similar footprint to the groundwater plume. There's one notable exception to the east along Washington Street. We think that this could be some overlap with the neighboring O'Neill's Cleaners site, which IDEM is working on concurrently. At any rate, this is on EPA's map, so we will continue to look at this area. This next map shows where we found TCE in soil vapor. This is Figure 5-8 in the Remedial Investigation Report and Figure 1-12 in the Feasibility Study Report. You can see that the contamination is not quite as extensive, and that it is in areas where we also found PCE concentrations in soil vapor above screening levels. EPA used the sampling data from the remedial investigation to analyze risks from the contamination at the site. We looked at risks to not just residents, but also to commercial and industrial workers. We assessed the risk posed by contamination in groundwater, soil vapor, and soil. When we boiled it down, the risks that EPA found to be of potential concern are from breathing in these contaminants if they get in homes or businesses, and from drinking untreated groundwater. Again, the city's well water is not a concern because of the carbon treatment. We always look for potential risks to the natural environment at our sites. In this case, we didn't identify any of these ecological risks, which is typical for a developed area like Martinsville. After looking at the data and assessing the risks they pose, EPA came up with a list of goals for cleanup activities, which we call Remedial Action Objectives in the Feasibility Study Report. EPA's goals for this cleanup work are first and foremost about protecting the health of residents living and working above this contamination. We want to make sure that no one is drinking the water unless it has been treated. We also want to make sure that we don't have harmful vapors accumulating in homes and businesses. So, how does EPA intend to meet these goals? We are proposing to actively treat the groundwater in the center of the plume, ensure that the carbon treatment at the drinking water plant continues, and monitor groundwater throughout the plume, with the intention of tracking the natural decline in concentrations. For soil vapor, we are proposing some active treatment in one or more areas where we have found particularly high concentrations of contaminant vapors in soil. We are also proposing, on a parallel track, to do additional vapor intrusion sampling and installation of mitigation systems to keep harmful vapors out of homes and businesses as needed. As with nearly all of our cleanup plans, we are also talking about using institutional controls to prevent human exposure. Institutional controls are legal measures taken to prevent activities that could lead to exposure. For example, we could ask the city to put in place an ordinance that would prevent people from drinking untreated groundwater, such as from a private well. We might also consider something that would notify developers of the potential for harmful underground vapors, so that they could consider putting in material to block or redirect vapors when they construct new buildings or homes. As I mentioned earlier, the feasibility study report is where EPA evaluated possible cleanup options. Whenever we do these evaluations, we always start with the option of taking no action. We do this to provide a basis of comparison to all of the other options. For groundwater, we initially looked at these 6 options. We screened a few of these out, then did a more detailed evaluation in a subsequent step. The first option we looked at is monitored natural attenuation, which involves monitoring the groundwater and tracking the decrease in contamination that occurs through natural processes. Our modeling showed that this is a viable option, so it made it through to the next round. Enhanced in situ bioremediation is where we add things to the groundwater to help the right set of naturally occurring microorganisms in the aquifer grow more and break down the contamination. Unfortunately, this option has a big hurdle because the chemistry of this aquifer is oxidizing, and the bacteria and such that do this bioremediation need reducing conditions. Reducing is basically the opposite end of the spectrum from oxidizing. Therefore, EPA determined that enhanced bioremediation would be a heavy lift, and we didn't evaluate this option any further. By the way, you see that we use the phrase in situ a few times here. That just means on-site or in place. For our purposes here, in situ cleanup options are those that involve treating the groundwater in the aquifer as opposed to pumping it out and treating it on the surface. Moving on, I'm going to group the next 2 options together as they are somewhat similar in concept, though at opposite ends of the chemistry spectrum. In situ chemical reduction, or ISCR, is where we add chemicals underground to break down the PCE using a reducing chemical pathway, and in situ chemical oxidation, or ISCO, is the same concept except we would use oxidizing chemicals. There are ways to break down PCE using either reducing or oxidizing pathways. Both of these options were deemed viable and made it onto the next round. We also looked at an option called in situ sorptive reactive media. Now, you may be somewhat familiar with this as they are starting to use one type of it to treat the O'Neill's cleaner's plume. This type of treatment involves injecting chemicals into the aquifer that contamination clings to. Often, what is injected is some sort of carbon. The issue with this option is that there isn't enough long-term data to show how well it works, and it is somewhat difficult to monitor. If you just look at the groundwater, it seems to go away quickly, but the contamination is still down there, and monitoring what is happening with it is difficult. We rejected this option in the initial round, but after getting some questions from the city after the feasibility study report was issued, I went back to our technical experts and asked them to do a deeper dive just to make sure we weren't missing anything. We all still agreed that there were too many unknowns with this option for EPA to be able to propose it. Finally, we looked at a cleanup option called in-well air stripping. This is also called air sparging, and would be doing the same type of thing that was done during the removal action back in 2005 to 2008. Air is injected into the aquifer so that the PCE goes from being dissolved in the water to a gas that moves into the soil above the water table. This might have worked well for the removal when it was done in a very targeted area on much higher concentrations, but trying to apply this throughout a much larger area would make it harder to control the vapors, which could actually add to the vapor intrusion problem. On top of that, this process works better with higher concentrations of contaminants. Just to summarize, EPA conducted a more detailed evaluation of monitored natural attenuation, as well as ISCO and ISCR. While all of these would eventually clean up the groundwater to meet drinking water standards, ISCO is expected to be the quickest at 15 years. I should mention that all of these are based on computer models, so they are just estimates. Of course, things can change, but this is the best information we had to compare the different options. It's also important to note here that even if we go with ISCO or ISCR, we would still be relying on some monitored natural attenuation to get to drinking water standards, because we're primarily talking about treating higher concentration areas. This is more common when we have large areas of relatively low concentrations. It takes a lot more effort, and you get much smaller reductions in concentrations when dealing with PCE contamination in the low parts per billion range. Add that to the fact that there is a large area of contamination to deal with, and it is not feasible to actively treat the entire plume. Now, of these three options, using monitored natural attenuation throughout the entire plume is the easiest to implement, and it poses the lowest risk from the treatment itself. The risks posed by the oxidizing or reducing chemicals are manageable. It is mainly keeping people away from direct contact with the chemicals before they're injected into the ground. Some more factors we considered are listed here. In situ chemical oxidation is a little easier to use than ISCR because the oxidizing chemicals can be more fluid and easier to inject underground than the reducing ones. ISCO is also expected to break down more of the contamination in the short term, though the ISCR chemicals might have a longer-term impact and the area treated might spread out a bit. However, we are more interested in knocking down concentrations relatively quickly so that we don't have to deal with the higher concentrations at the city's well field. Note that we can do more than one injection event if our monitoring shows that it's needed. This would override the benefits of the lingering effects of the ISCR. Again, we would be working uphill with the reducing option as we would have to change the whole chemistry of the part of the aquifer we are treating. That means more chemicals may be needed and more potential surprises if we go with the reducing step. Finally, ISCO is a bit more cost-effective than ISCR, though cost only gets factored in if all else is equal. This is how we believe the design would look for the groundwater treatment system. The lines on here cutting through the plume represent a series of injection points where we would inject oxidizing chemicals into the plume. We aren't proposing a specific chemical to be used at this point, but the one that seems most likely to be chosen if we go this route is something called potassium permanganate, which would be brought on site as a solution in a tanker truck. The solution is a purple color that can stand out as looking odd if you're watching it, but once it's in the ground, any risk to humans goes away. This would be done during discrete injection events, meaning we'd get set up and do the injections over a few days or a week or two, rather than continuously pumping material into the groundwater. EPA notes that it's very important that the treatment of the city's drinking water supply continues. We evaluated a few treatment options during the feasibility study just to make sure that it makes sense to keep using the carbon treatment. We determined that any of these would work well to remove the contaminants from the groundwater, but believe it makes the most sense to just keep using the activated carbon. We did a two-phased evaluation for the soil vapor cleanup options. As you can see, what we are evaluating here is different combinations of a few techniques. Pathway sealing is where we would try to seal up the basement slab or whatever is the lowest level of the house. This would involve filling cracks, sealing up sump pits, that sort of thing. As you can imagine, it's next to impossible to fully seal every possible pathway for these vapors to get in, so we didn't evaluate this method on its own any further. But we did consider pathway sealing in combination with other techniques. One thing we looked at combining it with is the installation of vapor intrusion mitigation systems, or VIMs. These VIMs are the same type of device that someone installs on a house to keep radon from entering the house. This method involves installing pipes that suck vapors from below the house or building up and outside above the roofline, where they are safely dissipated. Note that PCE breaks down quickly in sunlight, and the concentrations we are looking at are so low that these are diluted to safe levels as soon as they're vented outside. This combination of pathway sealing and VIMs made it onto the next round of our evaluation. The next soil vapor cleanup option we looked at is called source removal, which involves trying to remove the contaminated soil or contaminant vapors from underground. We believe that there might be one or more pockets of contamination underground aside from what we are seeing in the groundwater, and this cleanup option is about cleaning those up. The primary thing we would use as part of this option is to install a soil vapor extraction system in at least one high concentration area we found. The soil vapor extraction involves installing pipes underground that are used to suck out the vapors. Sometimes we will run these vapors through carbon before they're released to the outside air, but that depends on the concentrations and the amount of air we would be pulling. We also considered that we might have to dig up some contaminated soil as part of this option. We don't believe that it would involve a lot of soil, and any soil we remove would be replaced with clean fill dirt of a similar consistency. We decided to take this option on to the next round of evaluation because it is a viable option for solving the soil vapor problem. Finally, we looked at an option where we would do all of these things together. Seal up cracks in the basement where we can, install the VIMs on houses that need it, all the while working on getting to the root of the problem using soil vapor source removal. And this option made it on to the next round of evaluation as well. Again, we did a more detailed analysis of the soil vapor options that included pathway sealing with VIMs, soil vapor source removal by itself, and doing all of these things in combination. Of course, the last option is the one that we think would do the most to protect folks in the long run. We don't think it would be a good idea to just do the soil vapor source removal by itself because we think we'd need the VIMs to keep dangerous vapor concentrations out of some homes and businesses. At the same time, we think that the soil vapor source removal would significantly reduce the amount of time we need to operate the VIMs. In fact, we estimate that it would be less expensive to do this comprehensive approach than just the pathway sealing and VIMs alone. Now, the less we do, of course, means less hassle from a construction perspective, but we think the inconvenience of going into homes is well worth it since it means protecting the health of the citizens of Martinsville. While I'm on this topic of soil vapor, let me mention the fact that I expect that by early next year, EPA or one of its contractors will be sending out access agreement forms to property owners above the plume. These forms are how residents give EPA permission to come in and test air under and inside the property. To be clear, we will still reach out to you to set up a time to do the actual work. The sampling is free, as is the installation of VIMs if needed. We've done these installations all over the country. Here's a simple diagram of what a VIMs looks like. Piping is placed into a hole in the floor, which is well sealed, in addition to sealing cracks that we can get to. The pipe runs out of the house to a fan that is pulling vapors through the pipe from under the house to the outdoor air and above the roofline of the house. This is our typical design. If your house has something like an exposed dirt crawl space, we must put down some sheeting to function like the slab would, and the piping would start with a slotted pipe under the sheeting. This means more work, but it's still a relatively simple design. This figure shows a possible design for a soil vapor extraction system that could be part of the soil vapor source removal activities that we are proposing. This is in an area near the former Masterware facility where we measured relatively high soil vapor concentrations. The green areas represent where we think the soil vapor is located. Again, this is based on sampling from several points. And the darker green is where we estimate the highest concentrations are. The 9 circles with dots in the middle are where we might try to install these extraction points. The circles show how far from the extraction point that we expect the vapors would be captured. This is normally the part of the presentation where I would ask if there are any questions. However, just because we are doing this virtually doesn't mean I can't answer any questions you might have. My email address will be posted on a subsequent slide, and that is the best way to send me a technical question. In addition, Kirsten will be giving you some details on how to make formal comments for EPA to consider. You can also call into our live Q&A session on August 12th from 6 to 8 p.m. Eastern Time to speak with both of us. After reviewing your comments, we will reassess our plan and select a final cleanup plan in a document called a Record of Decision, or ROD. That ROD will include a responsiveness summary that gives responses to the comments we receive. Once the ROD is issued, I will work to get a contractor on board to design the remedy, then another to put it into motion. Once the remedy is up and running, we will be doing regular monitoring of soil vapor, groundwater, and the VIMS units. On top of that, we do comprehensive reviews every 5 years just to make sure things are progressing as planned and that we don't need to consider switching plans. These are called 5-year reviews and continue until the site is cleaned up.
To close things up, thank you all for participating in this virtual public meeting. As mentioned at the beginning of the presentation, there are multiple ways to submit your comments on this proposed cleanup plan. You can submit a comment directly on this website under the public comment form. Next, you can leave a confidential voicemail at 312-886-6015 or fax your comments directly to my inbox at 312-697-2568. You can also email me at safakis.kirsten@epa.gov, or finally, you can mail me a hard copy statement to Kirsten Safakis at the U.S. EPA, 77 West Jackson Boulevard, 19th floor, in Chicago, Illinois, 60604. And of course, if you have any questions or need assistance with submitting a comment, you can either contact myself or Eric. Thanks again.